Hello friends, this presentation is presented to you by Jayesh Patil and Sanket Navle. The topic for this presentation is Twitter bot analysis. The following slides gives you detail about the content which we are going to go through in this presentation. It starts with introduction. The second part of this topic would be based on motivation, what drives us to make this project, and to classify different users into bot or humans. The third talks about the dataset. Where do we get this dataset from? The fourth part talks about the initial inspection which we do on this dataset to clean the data, to format the data from its inconsistencies. The fifth part talks about the algorithm which we have used in this particular circumstances and the different performance metrics we gain through doing analysis on it. The sixth part talks about the conclusion, what we would recommend you to use in this particular scenario from the performance metrics which we got. So Twitter, as we know it, is an online news and social networking services where users post and interact with different messages and let others know their opinions. So as per the statistics which we gained through the Twitter site, there are 310 million active Twitter users and a total of 1.3 billion accounts at this moment in Twitter. Since Twitter can be such an influential program, people have developed different Twitter bots. They want to see how artificial intelligence can make different bots and act them as a real human. Many people do follow bots to see the updated news. The latest bot which I heard was about the Wikipedia bot, where there's a Twitter bot which posts different Wikipedia links based on web crawling. To continue with our presentation, the main aim of this presentation is to distinguish between the Twitter bots, to make a machine learning algorithm which could distinguish between a Twitter bot and a real bot given some attributes of information. The following gives you a perspective about different information which is presented to you through this data set. It talks about the user ID, username, status count, created at a timestamp when the account was created, location where the account is created based on, description, bio, which is called as bio, in which you could write, in which the user writes about its bio, description, followers count, listed counts, URL, whether or not user has given the account a URL, and the final is bots, whether the Twitter account is a bot or a human user. So this attribute has been used only in training data, because over there we use that attribute to train our data set, and then we use cross validation to test how good the accuracy is. So we use Tweepy, which is a Python library to gain the Twitter dataset. And so the motivation behind this project is all about the social media. So as per the statistics, there are 83% of Americans usually have some kind of social media account. Most of them use Twitter because that is the fastest social media which could reach many people instantly. And so what other people are trying to do is they are trying to make Twitter accounts which is artificially intelligent and which is able to fool other people and act as though it is human. So as artificial intelligence progresses, it might be difficult. It might able to fool people quickly, and it would be really helpful if we do have a program which could distinguish between bots and human people on Twitter. This slides talk about the dataset. The dataset which we glean through the Twitter APIs have certain different attributes. The following is the type of attributes which we had. Some were of integer type, namely ID string, which talks about the friend count, follower count, listed counts, favorites, what all different statuses has the user liked, status counts. The different type of attribute is string, which gives description about the screen name, location, description, URL, name, and language. Boolean attribute consider details about whether the user account is verified. Default profile, does the user account has default profile image, or does it has an extended profile? A date timestamp was presented with the help of the attribute of created at when the user account was created. Then there was an attribute status which gave description about all the different tweets tweeted by the user, which was in a JSON format. So the data set which we had, the data set which was presented to us had 1056 bot accounts and 1176 user account. This is a snippet of the account which we had so it gives details about different names, different description, all the different information which we just talked about. Now if you could see in the highlighted spot, you could see that the name has the first highlighted name which we have in front of us is every color bot. Then the next one is Hema Avari 8 bot, and you could see if you just glance down, you could see there's a name which is written as NES garbage bot. So what we could just see by looking at this highlighted image is that many of the bots account which we have the name bot present in their screen name. You could also see the same when you go through the description or the screen name. So this was one initial inspection which we got from just glancing through the dataset, and hence we decided to create a calculated attribute. The calculated attribute presents us with different set of attribute created from the information which we have. So we created the age of the account, which is done by using the date library. We use the date library and the date at which it was created to give the age of the account, like how old is the age, how much, and the next one is bot in name. We use the information from screen name, date, description attribute and see whether the word bot is present in those attributes. If it is there, we create another variable in which we have the listing about whether or not bot word is present in these three attributes or not.
Hi guys, I'm Sanket and I'll be continuing with the presentation. So let's start with the different classification algorithms we used for obtaining the predictions. K-nearest neighbor classifier, also called as KNN classifier, is a lazy learner. This is because this classifier doesn't actually build a classification model, unlike classifiers like ID3, which first build a classification model and then use that model for prediction. KNN classifier directly gives us the training set itself. So it uses the training set itself. In this algorithm, we calculate the distance of the training samples from the unknown sample and then determine the nearest neighbors of that sample with respect to the training data. We classify the unknown sample in the class which is most common amongst the nearest neighbors. As I mentioned above, a decision tree classifier generates a classification model and then uses that model for prediction. But decision trees often tend to overfit the data, especially when there are many outliers. In order to avoid overfitting the data and fixing the high variance and high bias, we make use of random forest. Now what random forest does is basically it makes use of a number of decision trees and output the class which is the most common amongst the output of those decision trees. Thus, by using this averaging technique, we find a natural balance between these two extremes and provide a better prediction. AdaBoost is based on the principle of boosting, where we use a number of weak classifiers to eventually build a strong one. AdaBoost is one such classifier which proved to be successful using the principle of boosting. This classifier makes the predictions based on the weighted average of the weak classifiers. AdaBoost is generally used along with the decision trees or decision stumps, but this classifier can also be used with other algorithms. Similar to AdaBoost, Gradient Boost again uses the principle of boosting. Now Gradient Boost makes use of three things: a loss function which varies from problem to problem, so it is supposed to be defined according to your need. Then we need weak learners, which are generally decision trees or decision stumps, and we need an additive model which can be used to minimize the loss or error. Gradient Boost performs better if we use regularization. In order to understand the performance of different algorithms we have used the method of cross-validation on the training set. As you can see from the diagrams, random forest gives the least training error, whereas KNN performs the worst in terms of accuracy. Also, the precision to recall graph suggests that the random forest performs the best. Adder boost and gradient boost also perform well, but not as good as random forest. So we can conclude that random forest was the best suited classifier for the data we used. Now, in order to further improve our algorithms, we can make use of different clustering algorithms like k-means or k-medoids to find interesting patterns, the way we find during initial inspections, which Jayesh told you about. We could have modified or cleaned our dataset based on those patterns. Also, we could have added different constraints, weights, or adjusted the feature importance accordingly. One more thing we can do is use the predictions of different classifiers, and after considering the accuracy of each classifier, we could have provided a final prediction. Also, we could have performed sentiment analysis on the status of Twitter accounts and included that knowledge also in our classifiers to improve on the accuracy. Well, that's all for now. Thank you for watching the video.